Good afternoon, ladies and gentlemen. Welcome to Tech Geek webinar series, our endeavor to empower techies. We believe that sharing of knowledge is the key to enhance our skills and grow us as professionals. With this principle in mind, we have initiated a series of webinars conducted by industry experts to give you all a crisp insight of various domains. The topic of today's session is Challenges in Testing and Automated Testing of Android Mobile Applications. Our guest speaker today is Mr. Vinod Doshi, Quality Engineering Manager at Synazip Infotech. Mr. Vinod Doshi is currently working as a Quality Engineering Manager with Synazip Infotech. He manages the team which is responsible for quality and testing of a new version 1.0 product on various mobile platforms, that is iOS, Android, WebOS, as well as Windows Desktop and Mac Desktop. He has 11 plus years of experience in software development and testing and has primarily worked with quality and testing teams in product organizations. Previously, Mr. Vinod has worked with Amazon.com, Microsoft, Adobe, and Symantec. He has been involved in design and architecture of complex scalable systems, has worked with several programming languages and databases, and driven software development projects end-to-end from requirements to deployment. He has experience in project management with various different software development life cycles. He has been managing teams and has been involved in interviewing and hiring since past few years. So without further delay, I introduce you all to our guest speaker, Mr. Doshi. Over to you, Mr. Doshi.
Hello guys, good afternoon. Let me just launch this slideshow. Cool. So yeah, the today's topic for the webinar is challenges in testing and automated testing of Android mobile applications. So I've been working in mobile for a couple of years. So I'll be going over what I learned about the initial part. I'll be going over what I learned about testing of mobile applications as such, and then I'll come to more specific information on Android mobile applications. So let me go over what I'm gonna cover in the agenda today. First, I'll talk a little bit about the growth and the prevalence of the mobile applications. Then I'll go over the Android market share and why is it important, why Android is becoming a very important platform, and why is it important to build and test applications on Android. Then I'll go over some of the challenges that are involved in testing mobile applications. Mobile applications are by nature different from desktop applications, and the challenges involved in them are very different from the traditional testing of traditional applications. So I'll go over that in details in this. Then I'll, from my experience, I learned some of the things over the past few years about what things are important in testing mobile applications. So I'll treat them as guidelines and mention some of those. Then I'll describe some of the current platform-specific automation tools for Android. I cannot go in details over each and every tool in this presentation because there are a number of those, but I'll at a higher level describe what the tools do and what they are good for. Then I'll mention some of the cloud-based testing solutions that are out there and what are the pros and cons of the solutions and how to use them. And then I'll also mention how to build a test framework which can work with one or more of these tools or use some generic tool in your mobile application testing. So that's in short the agenda for today. So let's start with the first thing, exponential growth in use of mobile applications. So it's a well-known fact that the number of people accessing the internet on mobile devices is growing exponentially, and the growth is to the extent that it's expected that in a few more years, the number of people who log on to the internet on mobile devices is going to be far more than the number of people who log onto the internet using desktops. And this is especially true of Asia and more populated countries. And a huge amount of population is gonna get access to the internet through mobile devices. So what that means is that there is a huge revenue opportunity, business opportunity in this. The primary way of accessing the internet and using the mobile is using the mobile apps. For iOS, there is the iOS app. For Android, there is the Android app, and for WebOS, there are the WebOS apps. For Windows Mobile, now they'll have their own app store. So primary ways to download and use the apps in these various app stores, and it is a huge business opportunity. Billions and billions of dollars of apps, consumer apps, are sold every day. So that is for the consumer part. Another important aspect is that until now, enterprises were traditionally using desktops and laptops as their primary mode of computation. Now, even in enterprises, people working for work reasons, employees are using iPads, Android pads, Android phones, and iPhones. So all the applications and the workflows that are used in the enterprise have to have these components or apps which can be accessed to the mobile. So if you look at the IT policy of any big organization right now, enterprise mobility is the buzzword. All of the companies are thinking about how they can take their enterprise existing workflows and include the mobile components into the workflows. So I mean, from all this, it should be pretty clear that mobile apps are the next, you can say, the wave in software, and the development and testing of these apps poses a different set of challenges than what was posed by the traditional apps. Also, the traditional SDLC, that is the software development life cycle, won't scale to the way mobile apps are developed. I'll go into the details of this a bit afterwards. And the traditional testing methodologies also won't work. So it's a whole new set of challenges. So let's since this is more related to Android, let's go over some market statistics of the Android. So these are the latest numbers from ComScore of the Android phone market. Google, there is basically in the table, Google is basically Android. Google OS, because Android is owned by Google, although it's open source, but it's still driven by Google. So you can see that even currently, the 50%, although iPhone is the one of the most popular phones in the US, and it's always in the news and media, and everyone is so crazy about iPhones. But if you look at pure statistics, more than 50% of the phones sold in the market are Android phones, and these numbers are specifically for the US market. This don't. I'll talk about the Asian market in the next slide. So it's pretty clear that Android phones have a huge footprint in the market. So what are the Android global market trends? Like I mentioned, there is a almost 50% plus footprint in North America. The one other aspect is that Android is struggling to get market share in the tablets. Until now, the majority market share has been for iPad, and a number of attempts by Android, specifically Samsung, and then by Motorola Zoom, have failed to take off. But with the launching of the Google Nexus and again the new Samsung Galaxy Tabs and with Kindle Fire, it is expected that within a few quarters, even the tablet market share of Android would be show significant increases. Another interesting part is that the Android tablet as well as phone market share has an exponential footprint in Asia. One of the reasons for this being Android is a open source OS, and it's easy since it doesn't cost anything. Any phone or tablet manufacturer can take that OS, modify it the way they want, and bundle it for free in their device. And since that results in a much cheaper device compared to proprietary software like iOS on iPhone. As such, if you look at Africa, if you look at Asia, a huge, probably the majority of the smartphones sold are Android phones and Android tablets. So Android is going to be the most dominant platform even in Asia going forward. So that was about, in general, about the mobile ecosystem and Android. So let's come back. Let's look at some of the typical challenges. At a very broad level, these are the challenges that are not just for testing but even in development for application on, say, a mobile platform like Android. One is the diversity of devices, platforms, OS versions, carriers, etc. So as if you already know a bit about Android, there have been very frequent releases, right, from 2.2 till latest is the ice cream sandwich, which is 4.x. So there is a lot of diversity in the OS itself, which leads to fragmentation. There is a huge amount of devices devices supporting all of these different OSs. I'll go into these things detail in a bit later. Again, due to the fragmentation, it results in multiple devices with different hardware configurations, image rendering capabilities. These three are especially important for Android. For a proprietary software, a proprietary company like Apple iPhones, or for, say, BlackBerry, it is much less because they tightly control the amount of types of devices, models of devices, and the number of OSs that go into the market. So it is it is not so difficult or not so problematic for them. But for Android, it's a huge problem. Again, short development and release cycles. Again, I'll go into this aspect in details a bit later. This is also typical of mobile software development. You hardly get a few weeks to a few months of time to completely release your app into the market. So let's look at this thing into details. Like I'll say that these are more business challenges, both for development as well as testing. Diversity of devices and platforms. Like I said, right from Android 2.2 to Android 4.x, there's a big footprint. So if you go back to those numbers, like 50% of the devices that are out there are Android devices. Anyone who plans to send an app to the Google Play Store or any other Android store, they have to actually sit down and factor in the percentage of the supported OSs in that 50%, and then figure out which OSs they really need to support. So that's kind of the fragmentation. So sometimes what happens is that some of the features are not backward compatible. If you are developing something for ice cream sandwich, some of the features you are using in ice cream sandwich may not be backward compatible. So sometimes developers are forced to develop different apps if that's a business need. Then that also poses a challenge to the testers and QA, where you have to verify that your app works across different platforms. So to cover this huge metrics due to fragmentation is a big problem. So that also poses financial problems. If you have to support such a large number of devices, it becomes very costly and time consuming to set up a lab and all that. Simulators are not always reliable, so you can do some basic testing on simulators, so you have to go back and do testing on the devices again. And coming back to the fourth point I mentioned, time to market. So like I said, the mobile apps is the current wave of software, and it's a gold rush. It's almost like a gold rush. It's like billions and billions and dollars of revenue in there. So the market is moving so fast. Also, the deployment is much faster than traditional desktop applications. So within a few weeks to a few months, you have to take your app into the market. If you don't take it into the market, your competitor will come up with with the app in that time frame, and you are out of business. So time to market is very short. I personally have seen even apps written from scratch and delivered to the app store within 3 to 4 weeks. It can be that short, and I have never seen a mobile app project, any software project in mobile apps where the software development life cycle is more than say 8 to 12 months. So a year is at most. So now let's coming back to the testing. So if you are going to test and develop these apps, right? So considering all the factors I mentioned, let's go over some of the challenges that are posed for testing such applications. One is the lack of physical devices. Say if you are releasing a Android application and it is supposed to run on, say you are supporting it officially on say 50 or 100 devices, but and you may be forced to do that because of the fragmentation in the market. You may be forced to support it on say 100 devices. It's not, and if you are developing multiple apps, it's not practically always possible to keep on buying devices to test your app. And 100 devices is a very small number. I mentioned it might go to 500 or even more than that. So investing and keeping such a huge array of devices is a challenge. And which comes to the next thing, creating a testing lab with physical devices can be very expensive, but you have to do it. I mean, you have to, especially in case of Android, you have to have a lab with this thing with a lot of devices, and it can be costly. Testing on devices versus testing on emulator. So considering that it can be costly and time consuming to set up all these devices, you have to figure out what all things you can test on a devices versus emulator and break that down. Lack of test automation. So in the early days of mobile development, all the mobile testing predominantly was manual. There was hardly any automated testing. Even today, I would say a lot of mobile testing happens manually. A lot of companies doing mobile development don't have the know-how and knowledge of setting automated testing and test labs and doing all of that automatically. Even right now, the testing happens manually. If you look at the desktop world, there are proprietary tools like Test, there is HP Quick Test, there are open source tools like Selenium, there are testing tools developed by Microsoft for Windows applications. So this kind of testing tools, prevalent open source or proprietary testing tools, are not yet easily available in the mobile world. It's still a maturing and developing community. So that is a big challenge to actually move from manual testing to automated testing. Again, like manual testing is time consuming and error prone, especially given the large number of devices. Some of the things that we take for granted in the desktop world, like code coverage, load and stress testing, device profiling, which we take for granted and which we do it very easily in the desktop world or in the web world, is very challenging to do in the mobile world, and I'll talk about it in a bit in the later. So these are at a higher level the typical challenges faced in the testing of mobile apps. Okay, one thing I would like to mention here before I go into the other details is non-functional testing of mobile applications becomes very important. For example, if you so this comes from the difference in a mobile, fundamental differences in a mobile device as compared to a desktop device. In a desktop device, you have abundant memory available, you have space available, you have processing power available, whereas in a mobile device you may not have all of that. Also, even if you have a higher end mobile Android smartphone which has a lot of processing power, the way the OS works is very different. If your application is typically starts taking a lot of memory or time, the OS may preempt the application, put it in background, or just kill it and get rid of it, which never happens in a desktop app. So this type of testing, non-functional testing, where is performance testing, where you see the response time of various functions of your application. Stress and load testing is basically if your application is under heavy load and heavy use, how does it behave? Device profiling is for testing memory leaks and how much resources it's consuming, and usability is the overall experience. You know, is it fast enough? Is it user friendly? All of that stuff. These things become extremely important in the mobile app. These things which would be traditionally non-functional testing in the desktop world becomes almost like a functional testing. This become requirements in a mobile world. And I would also especially like to stress on the usability and the UI. A typical mobile user will not use the application more than 5 seconds if it is not usable. The experience has to be very quick. Experience has to be very good. It has to be very usable. Otherwise, the user just kills the application. So usability becomes a very, very important factor, which also points to the thing that as a tester doing mobile application testing, you not only need to test it for functionality, but you also need to be kind of a product manager role. I mean, if you know about the product manager role, who has the vision of the product and who kind of develops the concept of the product and things from the user point of view, a QA or a tester kind of who is working on the mobile domain kind of needs to start doing that. He needs to start doing that as well while testing. So some of the key recommendations, I would say, I'll list down in the next 3 slides. These are based on my experience of and also my experience of some of the things I've studied in mobile application development. So one is follow agile methodologies for development. In a typical desktop and web application environment, a project might run for a year or 2 years and with multiple phases defined. It might be waterfall, it might be a bit agile or waterfall, it might be a combined model. And that might work out, but when you are developing a mobile application, especially on a fragmented platform like Android, and the shipping cycle is so less, there is no way you can get a quality product out like using a traditional waterfall model. So why is this important for QA? Is because if your project is not following a agile method, as a QA, you need to stress for it. You need to stress with project management that you, for ensuring the quality of the product, you have to follow agile, which again leads to very early development of QA, involvement of QA in the development. QA has to be involved right from the conception phase. Assuming that your app is going to market just in 3 months, you don't have to wait, or 3 to 4 months say, you don't have to wait till the 3rd month to involve QA and start testing it. It might be too late. It might work for a desktop application which has a year or 1.5 year or 2 year long development cycle where the QA might be involved late, but it will never work for a mobile application. Using BDD is behavior-driven development. I'll come. This again ties a bit with agile. I'll go into details of behavior-driven development a bit later in a couple of slides, so I'll skip it for now. Define the matrix of devices which are most important to you. So, like I said, due to the fragmentation, there is Android version 2.1 to 4.x available. Every phone manufacturer has multiple devices for every OS version out in the market. So, if you start listing down all the carriers and devices that you support, it might run into 500 or even more devices. But you can't possibly, efficiently release and test your application on all of these at a time. You might want to support it ideally, but it may not be feasible given the time constraint. So you have to narrow down your selection. You have to sit down and write down which are the devices you care about the most, which are the most important devices for you, and that has to be done by QA and product management right at the beginning of the product. Use cloud-based testing solutions. I'll again go into this a little bit in more details in a couple of slides, so I'll skip it for now. The only thing I want to mention about this is you can't possibly have all the devices, so to cover that range, you kind of have to, or it's recommended to use some of the third-party cloud solutions. Invest in automation. Automate early, automate fast, automate comprehensively. Like I said, even right now, even at this time, a lot of mobile testing happens manually. The community is not mature. People don't know the tools, and that prevents a good quality product from going out. Also, since the time to market or the development time is small, you probably don't have too much time to keep on running manual regressions. All this affects the product quality. Apps are frequently buggy, and you have to do frequent updates to the app after it's released to the market. So invest in automation. Invest in a test lab. Do not completely rely on manual testing. Select the right automation tool for every platform. This applies not just to Android but to overall all apps, because what's going to happen is that if you are developing an app, you are not just going to develop it for Android. In all the probability, you are going to develop it for multiple OS platforms, and one solution may not work for everything. So testing some things on every different device, you need device-specific tools for that. So narrow down on that. So the core functionality, you want to try to use the same set of tests on all across. So try to use some generic solutions for it. Don't neglect non-functional testing. I already talked it in a previous slide. What was considered non-functional testing in a desktop world is very important in mobile world. So don't neglect it. Be the customer of the product. Experience matters. Like I mentioned a few minutes back, experience really matters in the mobile world. How the user feels about the application, how fast it is, how it responds, the look and feel, the way it interacts with the users is very important, and users have very high expectations of a mobile application. If they don't like it, they are going to throw it away and use some other application right away. So a tester has to be almost like a product customer and a product evangelist at some point, and think about the product from that view and log usability bugs. Understand business and product management aspects of the application, which is kind of similar to what I said. Deployment and release can be tenacious process. This is another important aspect. When you are releasing to App Store, say Android App Store or iOS App Store or a BlackBerry App Store, they have their own set of requirements and processes. If you are working on a web, if you have a web portal, you can just do update to your web portal yourself, and you are done with it. You maintain all those systems. For a desktop application, you can send a CD or a download link, and that's done. But here you are relying on a third-party app store. They have their rules, and it often happens that an app gets rejected. You submit an app to App Store, and for some reasons it gets rejected. You have to rework, build the app again, do it, and this might happen several times. So don't underestimate the deployment. Take it into factor. Study the processes and the submission rules for the App Store properly, and take into factor that there might be some time needed to actually go through these iterations and submit the app to the App Store. So one of the things, just again due to the fragmentation and you cannot have all the devices, is try to do some testing on emulators. So this is just a table I tend to use in my testing to figure out what kind of testing I can do on an emulator and what should I do on a device. So most of the unit tests when you build can be run on a unit emulator. Some of the integration tests can be run on emulators. A regression test has to be run on a device, because a lot of bugs are device specific. I have seen bugs which are very device specific. If you go and try to reproduce the same bug on an emulator, it won't reproduce. But if you it always happens on a device. Moreover, it can happen on a particular device. So regression testing is should preferably be done on devices. Performance stress testing has to be done on devices. Emulators and devices are very different. So I mean, there's no option in that. You have to physically do it on devices. Device profiling again has to be done on a devices, and this is, like I said before, this is a very important factor. If your application is leaking memory, actually even if you performance, security, and device profiling, this kind of testings are even done by the company with the App Store. So if you submitted your app to Android, Google Play, or to iOS App Store, before approving the app, this testing is also done on your app by Apple or Google, and if it is leaking too much memory, your app submission will be rejected. So this kind of testing, you are better off doing it on devices well beforehand. Okay, so before I go further, I just want to mention how the rule of testing has evolved, over time. long back, maybe 2 decades back, testing was an afterthought. Developers built the application and sent it out, and it had bugs. But software itself was so novel that just getting the software out of the door was a big priority. The quality of the software wasn't a priority. Then quality started becoming a priority, but it still was the last phase in product development. Well, we have built this product, it's kind of coming to shape. Now let's get the test and quality team to test it out and find any bugs in it. So it used to come as a, in the last phase, say if it is a 2-year-long development, last 4 months would be involved, where quality and testing teams would be involved. Then companies realized that quality of the software is important, and quality teams and test teams started being involved at a much earlier stage. Then came agile and test-driven development, where QA and tests were recommended to be involved right from beginning. Now with the advent of mobile apps, the last stage, which is behavior-driven development, is becoming very important. So until test-driven development, QA guys used to work with developers to write test at the start of the feature, and so QA development was at the start of the development. That was recommended. Now with behavior-driven development, this goes one step still further. QA start working with product management, and tests are defined at the use case level. So if I am say, I'll give a simple use case. I have a simple mobile app, and the simple use case is I'll launch the app, login. So a use case would be a user launches the app, logs in, and then browses some functionality. So this use case, in these words, would become a test case, and you tie your code behind this test case and directly execute. So basically, you write your use case in the form of test cases, and you tie your test code directly to this use case and execute. So that's basically behavior-driven development. So again, to summarize some of the points, QA basically works very closely with product management to convert the use cases into test cases. Test cases are written as end user scenarios, because of which use cases can be directly mapped to test cases. And there are some popular tools available, like in the Java world there is JBehave, in the Ruby world there is Cucumber, which can be used to do this. I would recommend behavior-driven development, recommend it very highly for mobile development. I would recommend that every test team working on a mobile development app should do behavior-driven development and start using something like Cucumber for writing all their test cases. So before jumping into the different testing tools for Android, let me just summarize what all kind of Android applications can be there. Native applications, which are the most prevalent, basically it's a native Android application. Then the second thing is you have your website and you want to make it customized on Android phone. Basically, you don't want to load a heavy website, or desktop kind of a website on an Android app. So you start showing a different version, a lightweight version on Android app. Then you bundle your HTML5 application in a kind of a native way. There are frameworks like PhoneGap which help you do that. And then there are some other frameworks which like Titanium and RoMobile. RoMobile is all in Ruby. It's now acquired by Motorola, which you can bundle your app, which can work on cross-platform. So applications written in PhoneGap, Titanium, or RoMobile can work on all platforms. The same code can work on platforms like iOS, Android, WebOS, and all that. But still, the most popular prevalent applications are native apps and your customized websites for Android. And then the next one picking up very fast is HTML applications using PhoneGap. So this is a summary of all testing tools that are for all platforms out there. One thing to note is that, like I said before, this is a very weak community. Automated testing is still not become a norm. The tools are not mature. There's still a lot of work needs to be done. So some of these tools, if you start using them, you can find they are not, some features are missing, they need more work, but they are evolving. It will be some more time before the tools would become as robust as the desktop tools. If you look at the Android stack here, the most important one here for native applications is Robotium and the native driver. And there are a few paid tools as well. So let me come back to the cloud testing before I go into testing of specific tools for testing on devices. Let me talk a little bit about cloud testing frameworks. Like I mentioned, due to the fragmentation, if you are going to support 500 phones, you probably don't want to buy 500 phones and keep in your testing lab. You probably want to buy the 20 or 30 most important phones that you care about, test and develop for them, and then rest of the things you want to do on the cloud. There are many companies in the cloud. A couple of notable ones are Perfecto Mobile and Device Anywhere. So what these companies do is that they have their networks all over the world, and they have bought almost all the devices that are out there, and they keep on updating their device inventory, and the devices are plugged to the net. And you can get a device on rent, and you can, so if you say I rented 20 devices, so you can keep on getting devices on rent and keep on using 20 different devices every time to test your app. So tests can run on several devices in parallel. There is a web interface for running and writing this test. So you can do the automation using their tools, using a web interface, and run the test. You can have build integration. If I'm setting my builds on Bamboo, I can just, when my build is ready, I can just using an API push the build to say Perfecto Mobile and kick off the test there. Other features like, if an incoming call comes on my phone, how is it being handled? All of those features are also available. Automated test execution is recorded to video, and videos as well as device logs are available after the recommendation, so you can actually go back and if you see error in the log at a particular time, you can go back and see in the video what exactly happened. After your use, the device is cleaned off and given to another user for his use. So these are the this is about cloud-based testing frameworks, and these are the advantages. Of course, there will be some disadvantages. So what are the disadvantages? It's a subscription model. If I say I'm going to support 20 devices, then I keep on paying for 20 devices every month until I support it. I have to pay on every month, so it's a recurring cost. They are very costly right now. So it's not something where you want to do bulk of your testing, but you still want to invest. So you want to do bulk of your testing in your own test lab on your own 20 or 30 or 40 devices you care about, and then the remaining huge array of devices, you probably want a few months of subscription on this and go and finish the testing on that, and that's it. Another disadvantage is in lock-in. Like I said, they have their own frameworks which are very proprietary for writing automation and tests. So you log in into their websites and frameworks, finish the tests and write them and automate them, but you cannot export and use them again. All your test data and all your test automation is stuck on their framework. So you are kind of locked into them. So that's obviously a disadvantage. Internet connectivity issues. All of this is over the web. So if there are connectivity issues, your work would be hampered. Automation is image-based, time-consuming, and taxing. And like I said, automation cannot be used outside the framework. You're stuck to them. But the cloud-based testing solutions are still good to provide additional coverage to your devices which you don't care about too much. So now let me go over some of the important tools for testing on Android devices. Robotium. This was the earliest tool. This was testing for native apps. So this was, I think, the first tool for testing native apps on Android, and this was most widely used before the other tools came. And this is specifically for Android, developed by Google and kind of widely used. So yeah, I provided the going in details of the design and the architecture of every tool is kind of time consuming, out of the scope. So I'm just of this presentation. So I'm going over the most important tools in brief. Next one is Selenium Android driver. But before going on Selenium Android driver, I want to talk about Selenium first. So most of you guys must have heard about Selenium already. I've given the link. It's the open source browser automation tool. It's the one of the most widely adopted, probably the most widely adopted browser automation tool there. Extremely active community, very evolving and very good community support, and the features are being actively developed. Supports a large number of browsers. Probably I think every browser I can think of is supported. Firefox, IE, Safari, Chrome, everything is supported. For Firefox, you can even do record and playback, so that your writing of test cases is reduced. Provides support for writing test cases in multiple languages. There is Java, Ruby. There's a lot of languages. I think there's C#, so you can start writing tests in any language that you are comfortable in. And one of the very interesting features, so all this that I talked about till now is mostly for standalone browser automation, right? I launch a browser instance and test my application using all these tools. But what if I am testing something like a website like Facebook, where a number of users can log in and do interactions and all of that? Then I need to launch multiple instances of the browsers, log in as multiple users, and do a lot of interactions. So there is something called as a grid, Selenium grid, which is really which is amazing stuff actually. You can launch a grid. You can tell it which all VMs are which all VMs can be launched, and it can go and launch different browsers with different user profiles, and at the simultaneously execute your Selenium scripts on different browsers. So you get multi-user testing using Selenium grid. So this is one of the very powerful tool or powerful thing you get when you are using Selenium. So that was about Selenium. So like I said, one of the types of Android applications that can be out there is HTML5 apps like PhoneGap, or you might want to just test your website on Android phone or Android tab. So Selenium, like I said, it's active community. So the next thing coming up in Selenium is the Android web driver, where you can launch a Selenium, you can write Selenium tests and run it on your Android device or an emulator. Again, this was developed by Google, possible integration with Selenium grid, and with some tweaks. I'm not completely aware of the details of the last thing, integration with PhoneGap, but it is possible. From what I read so far, it is possible to automate PhoneGap applications using Android Selenium Android driver. So this is quite a useful tool which is under active development now. So this is another tool, native driver. This tool is in early stages and is still development. Again, this is by Google. The agenda of the development of this tool is very ambitious. So Selenium is very popular not only because it's widely used, and it has a very user-friendly API. So what native driver is trying to do is use some of the components of the Selenium architecture and use almost all the API of it, and add more API to Selenium, and provide the similar application programming interface for testing Android native applications. So the goal is very ambitious. It's still an early stage and evolving code base. Like I said, attempts to bring Selenium API to automate native Android applications, but it's still not widely adopted as yet. But it's a Google project, and Google, when Google supports a project, they eventually come out to be very good. So this should grow into a very good tool going forward. And there are other proprietary tools, like there is Monkey Plant from. Actually, I swapped the links. Names and links should be other way around. That's a mistake. There is Monkey Talk from Gorilla Logic, and there is Eggplant from Test Plant. These are proprietary tools, pretty much based on image comparison, but they would cost a lot of money since they are proprietary tools. Okay, now one more. I talked about three things. One was cloud-based testing solutions. Second was about some Android-specific automation tools. Now there's another thing which can be helpful. If you are developing an application not just for Android, but you want to support it on a number of platforms, and you want to write test automation on one platform and make it run on anything else. So this is where Sikuli comes in help. So what is Sikuli? Sikuli is basically image-based test automation. It basically using image capture and graphics to automate things like click, drag, drop, and all of that. Visual verification of output, not dependent on the platform beneath. It can run a Sikuli test can run on any platform, including desktops as well as mobile devices, and can be used on an emulator as well as device. So I'll go into a bit depth of what Sikuli does. So what is Sikuli? It's a visual technology to automate GUI using images. It's a MIT research project. It's widely supported, very active community. There is a graphics and computer vision library called OpenCV. So Sikuli is built on top of OpenCV, and OpenCV itself is a very active community and very popular and very well-developed library. So that benefits Sikuli as well. Sikuli provides a Sikuli ID, or you can use developing instead of, if you don't want to use the Sikuli ID, if you want to use Eclipse, you can use Eclipse instead of the ID. It has its own API for programming, and basically works on image capture and screen matching, and works on all platforms. So what are the advantages? Can accurately test GUI and rendering of applications. So if I launch on say mobile, if I say if I launch a screen and I want to verify that after launching on screen there is a particular content at this point, you can it's very difficult to do using a conventional automation tool, but very easy using Sikuli, because it works on image recognition and image matching. All you need to do is take a screenshot and compare it using OpenCV, and that's it. Because it works this way, you can write test cases outside the device. It's not platform dependent. You can write test cases and run it on any platform. Can perform on emulators as well as devices, and it's easy to automate. So the limitations are it highly depends on resolution, of course, because it's a image recognition tool. If your resolution of your images changes, the test might fail. You can specify a threshold saying that, you know, if there is a 80% match, give me a yes, but there's still limitations to it. It cannot run in background, so you cannot run it just, you know, as a background mode on a build system. It has to have a dedicated machine where it will run in foreground. And until now, the support for gestures is limited, like swipes and all of that, but it's coming. It will be there soon. So one last thing I want to talk about is, so I talked about this number of tools, right, which were specific to Android platform as well as Sikuli, which is the image recognition tool, and I talked about cloud-based solutions. So this framework that I'm going to talk about is very similar to what the cloud-based frameworks might have. That's my guess, that they might have developed it internally. But if you want to develop something like that internally to be run in your own organization, what kind of framework overall you could develop? So end-to-end framework I'm talking about here. So I'll say first recommendation is use BDD using Cucumber or anything else. All your test cases should be in BDD. You should have a test case management tool like TestLink, or if you want your own proprietary, that's fine, but everything should be there and you should be able to pick off tests from it. You should have virtualization server. It can be, you can have virtualization images on EC2, or you can set up your own virtualization server like a ESXi server, VMware server. Then you can get a number of your devices and plug them to a USB hub where you can access them from these virtual images. And you can import the UI of those devices onto the virtual image, for example, using Screencast on Android or using VNC server on iOS. And then you can use Sikuli or any other platform specific tools to run tests on this, and basically, and then you can also integrate all of this to Bamboo or your build management system. So this is kind of a overall end-to-end framework you can build, and this is not too difficult to build. Once you do a right selection of the tools. All you need to write is Fabric to weave it all together and use virtualization to weave it all together and build a kind of a test framework which can work in-house, just like a cloud framework, but more in-house. Yeah, and these are some, I've listed all the references about the different tools and devices that I talked about. Yeah, that's about it. So that's, if you have any questions, please send them out. I'll try to answer as much as I can. Android, so one question from Umesh was, Android is owned by Google, then how it is open source? Android is not owned by Google. I mean, well, when you say something is open source, you release it as per a license. So even though Google drives and owns Android, the license under which someone else can use this thing is a open source license. So the license is more important when it comes to open source, the kind of license rather than who owned it. So the next question is, why do we need stress load testing when the application is expected to run on a single device anyway? Not all applications run on a single device. A lot of applications, for example, if you use something like Dropbox, which is very popular, talks to a server behind it, sends your files and things. So a lot of applications talk to a server behind, typically sitting on EC2 or Windows Azure cloud, or some Ruby cloud, and it talks to the server. So a lot of applications do that. So you need stress testing for that. Typical life cycle of an Android app. What is typical life cycle of an Android app if applicable? Well, typical, as far as from requirements gathering to deployment, the life cycle or the things that you in a desktop app are same things you do in a Android app. The difference is that it's very short and compressed. You have to release your app in 3 to 4 to 6 months. Like I said, I've never seen a Android app project go on for more than a year. A year is max I've seen. So the duration is the difference. What's the integration test strategy to test end-to-end workflows? So it is part of your use case integration test. Like I said, you can use behavior-driven development and map your end-to-end use cases to test cases directly. And second part is, like I said, you can build a test framework where you can execute this. How can we do usability testing in mobile application? That's the question. Well, like I said a number of times in the presentation, as a QA, you kind of become a product manager. I mean, you have to start thinking like a product manager. You have to, when you are testing the app, you have to think like a product manager and figure out, as a user, is the app good? Is it responding fast? Is it good enough compared to the other apps? Is it addictive? Do I feel like using it again? So I don't think there is any specific thing you do. You basically become a user and a product manager kind of thing. You wear that hat and do it throughout your application testing. What is a native Android app? What are other types of apps? Native Android app is basically using the Android SDK. App has, Android, or if you see how to develop apps on Android, there is activities, then there is another way to do it, there is a web view. So basically using the Android SDK, you basically develop an app. That's a native Android app. like I mentioned, the other types of app are app bundled on top of a framework which runs on Android. So Titanium, PhoneGap, RoMobile are frameworks which run on Android, and then you develop your app on top of that and release it. How effective is it in cloud testing tools due to availability of assured bandwidth dependency? I think in most of the companies now, bandwidth is not a problem. So cloud-based testing solutions do work out well. If you are testing from home, it might be a problem because people at home still have limited bandwidth lines, but most of the companies have internet lines with a lot of bandwidth, so that doesn't become an issue. Yeah, I guess that's I covered most of the questions. If there are any other questions, you can feel free to send it to me. Yeah, one more question is, which one is the best tool you would suggest for testers who can use to test apps on different OS? If you are short on time and if you are supporting multiple OSs, I'd say automate using Sikuli. You do image-based automation using Sikuli. You can test your record and play your test on one platform and pretty much run them on all your platforms, provided your app behavior is same on all platforms. Another question is, can we do load testing on Android application through Sikuli? You can do load testing. I mean, Sikuli itself does not add too much time lag in what it does. So it's not like it slows down your application. So you can very well do load and stress testing using Sikuli. Basically, you write your Sikuli test, and then you write in your test framework, you can spawn multiple threads and simulate your load to simulate your load and do that testing. Another question is, can Selenium Grid be used for testing on multiple devices or multiple browsers on the same device? Have you tried it before? I personally haven't tried Selenium Grid. I'm about to try it in one of the projects. But Selenium Grid can be used on multiple devices as well as multiple browsers on the same device. You could do both using Selenium Grid. Another question is, how do we address scalability of mobile applications? So like I said, if you look at really very few mobile applications are device based only. A lot of popular mobile applications out there are client server apps. The client sitting, or either client server apps or they are peer-to-peer apps. So your your app sitting on the mobile is either talking to peers or communicating with servers, and most of the time the server is on the cloud. So scalability becomes important. I mean, no question about that. And you have to do scalability testing. You have to do scalability testing at the server level as well as scalability testing at the client level. And basically, it's just your functional testing. You have to build a scalability testing framework. Unfortunately, like desktop applications where you can use something like load runner, which is built in, there is no mature load testing framework as such. So you have, once you have written and automated your functional tests, you have to write your own load testing framework to test it. Yeah, why do you advise regression testing on a device and why not an emulator? Okay, the reason is when you have reached the point of regression testing, your product is a kind of mature. It is closing to release. So in the initial phases of the product, you probably are not testing frequently on every build. The product is still in the conception. By the time you are reached the stage of regression testing, you are running tests on every build, and you're probably a few weeks away from release. So you want to catch the bugs which the customer might see, And the bugs that a customer might see are going to be on the devices. They are not going to be on emulators. So you want to test as close to the real environment as possible. That's why regression testing, you try to do it on the device instead of the emulator. Another question was, which tool can we use for performance testing of Android apps? Like I said, unfortunately, there is no load testing tool kind of available. What you do is you automate your Android test cases using one of the tools that I mentioned in the presentation, and then you write either use a third open source framework like Grinder, or you write your own threading and load testing framework to reuse your test to stress the application. Pretty much you have to do that. Like I said, the automated testing overall tools and community is not very mature. This is still, the tools are still maturing and upcoming, so you'll have to do a lot of coding and a lot of customization to get things like load and performance testing done. So I guess I answered most of the questions. Are there any other questions? So is that it? Please send me if any other questions.
I've sent you a lot of questions. Can you please resize your window and check whether the questions
I
are
answered
appearing?
most of them.
Okay.
I answered most of them.
Sent you a few more.
Okay. How effective is Selenium for mobile testing, as the requirements tend to change within weeks? Selenium, if you are building a HTML5 app and if you are able to test Selenium with it, there is nothing like it. I mean, I'll say just go for Selenium. It is an awesome tool. It's very agile. It suits very well in a agile or a Scrum development kind of model. So, I mean, big thumbs up to it. You should totally use it. Device profile, which tool can we use for device profiling as an testers? I don't remember. I use some tools for Android. I don't remember top of my head which tools are there, but there is a set of device profiling tools specifically which come as part of the Android OS. So it's pretty straightforward. Unfortunately, I don't remember it top of my head, but it's pretty popular. Even if you Google it, you should get it, and pretty straightforward to use. Another question is, which one is best for testing web services data, emulator or device? Well, emulator or device is nothing, should not be tied to what you are testing, but at what stage of the life cycle you are testing. When your product is in your early stages and conception, a lot of things are breaking. You're better off testing on emulators while it gets to shape, even if it is web services. And as you are getting close to release and your product is stable, you have to move to devices. Don't use emulators. Keep on testing on devices. So the distinction is more at that level. Another question is, what would you suggest if app is under development? For that, we can use the automation tool. Yeah, like one of the things I mentioned in the presentation, people even now tend to do manual testing of mobile apps, and it is not advisable. Invest in automation, invest in the test lab, start early on, and use BDD. Start writing your automated test cases right from day one. Another question is it possible to move to mobile testing from manual testing? If you could please suggest me if I need to take up any testing course related to mobile testing. Unfortunately, I don't know any testing courses offered by third-party, institutions and all that. Everything I learned is on the job. So I've been working for a while, so everything I learned is on the job. So I don't know any external courses you can take up. But most of the tools I mentioned, a lot of them are open source and are available out there on the net. So I don't think you don't even need any testing course or something, you can just start down. For example, Robotium is available open source, Sikuli is available open source, Selenium is available open source. You can just download the tools, start using them, start looking at the source code. If you are really enthusiastic, you can even do fixes. You can even provide fixes to the bugs they have. So I think you don't need any courses for that. Just get the tools and start working with it. Another question is, can you give the example of test-driven development with agile methodologies? So behavior-driven development is test-driven development taken to one more level. So what you do in test-driven development is, as a developer, if I start writing, say, a few functions, I start writing test cases which fail, and then when my code is complete, and I make the test cases pass when my code is complete, and then I say that I check in the code. So that's test-driven development. Behavior-driven. So you still do that with agile. I mean, with what I mentioned in mobile. I mean, you still do test-driven development, but that happens at kind of the unit test level. You go. What I mentioned is that you go one step further and do behavior-driven development, wherein behavior-driven development, wherein you not only do TDD, but you tie your test cases to use cases. For example, if I'm using, say, a Dropbox kind of application, and my my use case is log on and drag and drop a file. So that use case become a test case right away. You use something like Cucumber or JBehave to write code behind it.
Well, thanks, Mr. Doshi. That was all we had for questions. Thanks for the insightful presentation on challenges in testing and automated testing of Android mobile applications. It was indeed a great session. I would also like to thank all our participants for the support in making this webinar a success. The recording of this webinar will be available on techgeek.com by tomorrow. Thank you all. Have a great evening.
All right. Thanks. Bye.